Hi everyone. Today we're going to be talking about archaeology. Um, Archaeology is really a subfield of anthropology. And so this is the subfield of anthropology where we study prehistoric cultures and their remains. We do not deal with human bodies. Those would be dealt with by physical anthropologists. So first of all, a couple important things you should know. Archaeologists do not study dinosaurs. My in-laws often think that this is what I do. Um, so let this be a message that dinosaurs do not equal archaeology. We also don't just look for pretty things or spend most of our time digging. In fact, most archaeologists spend most of their time in the lab and doing processing of artifacts and analyzing data and things like that. Archaeologists also don't sell anything that they find. And in fact, in order to export materials, it's quite a long process usually. So most of the time, archaeologists study the objects that they find in the country that they're found in. So what is archaeology? It's a systematic and scientific recovery and analysis of artifacts to answer questions about past human culture and behavior. Archaeologists do things in a very measured and methodical way, hence the term systematic. We need to be able to record everything that we've done very carefully because archaeology is a destructive type of research. So as you're digging down through the dirt, you're removing things. And therefore it has to be well recorded and very systematic. Otherwise we would just be grave robbers and looters of archaeological material. So the next few slides are going to be information about some of the basic parts of archaeology. So first of all, archaeologists study artifacts, and an artifact is a human modified or made object. So this is not something you just pick up and use as a tool, so not like a stick you might use to knock an apple off of a tree. If you had carved the end of that stick, then that could be considered an artifact because you've now modified the natural state of the wood. Some of the more common artifacts we find are potsherds, stone tools. Sometimes we find metal objects, occasionally carved bone. And in rare cases, we do find basketry and textiles, even though these don't preserve well in most environments. For example, in New England, where UMass is, basketry and towels would be almost impossible to preserve because the environment is, very wet and is hot sometimes and cold others. On this page, I put a potsherd for you from the site I work on in Cyprus. And I don't know if you can tell, but there is an inscription on it. There's some Peruvian textiles and also coins. And coins are also not quite as common as pottery and other stone objects, but it's actually really exciting to find a coin in the field because it's usually made of some kind of precious metal, silver, gold, or a mix of them. So I just spoke a little bit about preservation, but here's a little bit more detail. So again, not all artifacts preserve. So pottery and stone, metals, things like that, those preserve really well. Things like wood and textiles will only survive in like a tundra or a desert environment, and that's because there is, less moisture and it's sort of an airtight environment. So on this page we have the Dead Sea Scrolls in the top corner. And the Dead Sea Scrolls survive because it's extremely dry in the cave that they were left in. There's also a picture of the Tolland man. And he was found in a bog, actually, which is really interesting because bogs are also a really good preservation environment because there's not a lot of oxygen in them. And in terms of other things like fossils, these would be excavated by paleoanthropologists, and they survive in varying conditions because of pressure and the amount of time that they've been there. So preservation is really quite important. Pottery, stone, metals, these things usually survive in any environment, but a lot of other materials, leathers, cloths, things like that, will only survive in very dry or low oxygen, waterlogged environments. We also excavate things called ecofacts. So these are not artifacts, but they are still important in the archaeological record. So these are material remains that are not modified by humans. So an example of that would be animal bone or teeth, ash and charcoal, usually results from a fire or some sort of destruction event, hearth. The picture on the left is like a stratigraphic or a side profile of an excavation unit in the United States, and you can see kind of in the center that it's very black, and that would be ash and charcoal. So that would be an example of an ecofact. On the right side is just the lower skeleton of a large mammal, probably cattle. And so these would be ecofacts, and they can tell us about some things in regards to past human cultures, but they are not artifacts. Something else archaeologists excavate are called features, and these are usually stone, or if you're doing a historic site, a feature could be wood, if it's a historic house, something like that. So features are built objects, and they include walls. Sometimes we have sort of strange anomalies, like in the bottom photo of standing stones, and that would be considered a feature. A pit can be a feature. Actually, in that last slide, that hearth would be considered a feature. So basically, features are anything that's kind of permanent and made by humans. So it's like an artifact that you can't move easily. Archaeologists do most of their research on sites, and a site is basically just a place where there's a large collection of objects. This map here on this page shows you a river valley with a whole bunch of sites dotted on it. So when you're trying to choose a place for research, you're going to first do survey and figure out where things are, and then you will call something a site if there's a large enough collection of artifacts. Another important part of archaeology is during the digging process, you find things called, you find artifacts, excuse me, and we call them in situ when we first find them because they're in their original context. And that means that this is where they were before they were removed by archaeologists. And we try to record the context of especially big things like this pottery jug. And knowing the context of where that object came from is very important for sort of reconstructing the site. Something else very important is the idea of stratigraphy. And stratigraphy is really a geological category, and this is just the layers of dirt in the order in which they were deposited. And so on this right side photo is a pretty deep cut in an archaeological unit. Test unit, and the dirt is the stratigraphy. So that whole long large layers of dirt is the sequence in which the dirt was laid down. So archaeologists need to understand what was there and when, what kinds of soil, what kind of deposition event there may be, how features like the wall in this picture relate to the different dirt layers. And all of this is stratigraphy, or the studying of soils and deposition. So we use stratigraphy to get sort of relative datings of things. So what was there first, what was deposited later, things like that. So archaeologists use two different dating methods. One I just mentioned, which is relative dating, and this is a generalized dating system where you assign a date like archaic or classical rather than a number based on surrounding materials. Some archaeologists, if they don't know like what kind of category it would fall under, so for example, archaic and classical is used in the Mediterranean world, You might use phase 1, phase 2. So these are dates that are directly related to each other, but are not necessarily on a timeline. Now, an absolute date could be put on a timeline. 1965 would be an absolute date. And these are based on scientific analysis like radiocarbon dating. Radiocarbon dating is often cited in publications as BP, which is before present, and present is actually 1965 when radiocarbon dating was first used. So any date that has BP next to it is from present is 1965. So now we'd have to add 50 years to that to get to contemporary date. And absolute dates are not actually exact for the most part. A lot of radiocarbon dates come with a sort of plus or minus 200 years or something like that. So at least it's a bit closer than relative dating. Within relative dating, we have this idea of seriation. And seriation is the idea that all artifacts appear, flourish, and then decrease. And we call this a battleship curve. So on this page is a pretty famous example from New England of tombstones. And someone went and studied sort of what was popular and when. And so the middle tombstone is the clear battleship curve. The other ones are sort of fading in and fading out. So seriation dating is important because it shows us sort of patterns of use, what people liked and when, things like that. All right, so a little bit of history for you. We don't need to get too much into this. You just need to be aware that the first, what we would use a loose term of archaeologists, were actually just antiquarians, and they collected artifacts. They traveled around the world and did some, probably not completely ethical things and to acquire artifacts. Our first real early scientific archaeology started in the early 20th century. And really, archaeology started because we were really interested in the evolution of humans at this point. So archaeology kind of formed out of several other scientific disciplines. And people were just using it to record as they sort of removed skeletons and things like that. In the 1920s, we became a fully scientific discipline, hooray! And like technical reports were filed, good recording was done, things like that. This is the time of like Flinders Petrie, who's someone you've probably heard of from Egypt. And in the 1960s, we had a lot of advances in science, and so we started adding a lot more methods to what we were studying. So it was no longer just sort of an assessment of the historical projection of prehistoric populations. Now we started getting into the sort of nitty-gritty about, what were they making and why, and what does this represent, things like that. So the next few slides have some examples of these more scientific analyses. So the first is petrology, and petrology is what I do, actually. Petrology is the taking of rocks or potsherds and grinding them down to about 3 micrometers thick and putting them on slides. And this way we can use what's called a petrological microscope to analyze the mineral content of potsherds or rocks. And the reasoning behind this is to figure out where things came from. How were they traded? What's the specific production style of potsherds? So in the 2 bottom photos, these are photos of the mineral content of some of the potsherds shown above. And the minerals in here include rock fragments, there's some feldspar, there's some shell actually, and the big red globs on the right side are fragments of other potsherds that were ground up and added to clay from like a new clay. And all of these things will give us an idea of where these came from, because when you compare the mineral content of a potsherd to the geological area, you can tell if it's a local clay or if it was an imported clay. Some other analyses we use is one being dendrochronology, and this is using tree rings for dating, which seems kind of difficult for archaeology because we know that wood doesn't really survive well, but sometimes we get burned wood fragments, and these can be used for dendrochronology because we can figure out the rings of the tree if it's like a good chunk of wood. Dendrochronology is mostly used in historical archaeological projects because they actually do have wood that survives on houses and things like that. So it's pretty interesting, and using dendrochronology we can get a long sequence of dating based on different trees. Another analysis that's done is lipid analysis, and basically if you find a potsherd that has residue on it, you can test that residue to see what it is. Some kind of oil or resin, things like that. And in fact, a pretty famous shipwreck called the Uluburun, which was a Bronze Age shipwreck off the coast of Turkey, archaeologists have found that they used a particular type of resin to seal the inside of transport jars so that wine didn't spoil. We also have a residue analysis of actually snails that had been sort of attached to the pottery on the outside, and based on the sort of slime from these snails, we know where those pots came from, or at least what port they were picked up at. So all of these things are really interesting ways to use hard science within the social science of archaeology. Archaeology also has goals. There are three really specific ones that most archaeologists use, and the first is cultural history, and this is really the sequence of events of how and when things happened. We also look at how artifacts change over time, and within the idea of cultural history, we develop things called typologies, and these are, what kind of pot is popular, and how does it change into a different type of pot, and then we can use, based on a typology, we can look at some seriation dating of it, and determine sort of sequence of events in that way. Lifeways reconstruction is looking at technology, different types of exchange or trade, ideology, social organization, settlement patterns, all of these things which allow us to figure out, the sort of daily life of people, not just, how they died, but think about based on what's buried with them, well, maybe they were a soldier or a potter or a wife or a husband. All of these things can be investigated. And then finally, culture process is basically making theoretical models on these lifeways. And these theoretical models serve as examples for other sites in different parts of the world to compare to. And finally, in archaeology, we have kind of three types of theory that we use. So low-level theory is statements based on what is physically found. And so this is the lowest type of theory, meaning that we only focus on what's at that particular place. So we might, low-level theory might be, at, site B, they used cooking pots in the kitchen, right? So that's based on the types of pottery that's found, things like that. A middle-level theory is a little bit more advanced, so that we would link human behaviors to those artifacts. So going on the one I already suggested, we could say, well, at site B, they use this particular type of cook pot to cook this kind of food. And so we could look for patterns and behavior to determine, oh, well, maybe only, certain types of people, certain social classes use that kind of pot, things like that. And then finally, high-level theory is when we use a lot of sites and a lot of artifacts to address these big questions. So one of these big questions was actually covered in your first lecture, your intro lecture on civilizations and things. And this is where B. Gordon Childe came up with his idea of the urban revolution. So why and how did people develop urban environments, and what characterizes an urban environment? So he actually looked at a bunch of sites and came up with a list of things that would suggest an urban or a state level society. So this high level theory really required him to look at a bunch of different sites. You can't just look at one and make a statement like that, because then, it could be easily disproved by just looking at one other site. All right, so these are some of the things that you'll come across in the coming weeks as we do some readings on archaeological cultures and things like that. Most of the readings for this course, actually I believe all of them, are based on archaeological material. They are not really historically defined, and for the most part, we don't actually have a lot of sort of historical narratives for a lot of these cultures.